All right, let's continue talking about quadratic equations. We've already talked about solving quadratic equations first by factoring, all different types of factoring techniques we've talked about in the past in order to solve. We also talked about if you can't solve a quadratic by factoring, then you can use the method called completing the square. We did that back in the previous section, 11.1. Now, in 11.2, we're going to learn a third method of solving a quadratic using what we call quadratic formula. Well, if you look at the beginning part here, what your book has done is proven the formula, the quadratic formula, by taking the standard form of a quadratic, ax squared plus bx plus c equals 0, keeping the coefficients of a, b, and c, and actually working through completing the square to solve for x, using just the numbers a, b, and c. And they found that this works every single time. So really, what the quadratic formula is just completing the square. So we have three methods now: factoring, completing the square, or this formula now that we can use called the quadratic formula in order to solve any quadratic equation. Using the coefficients a, b, and c, as long as your quadratic equation is in that standard form, where you have it in descending order, everything's to the same side equal to 0. You should be able to use those three coefficients and plug those numbers into the formula to solve for x. You might have heard of it before. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Make sure you memorize that. You're going to be using that a lot. All right, let's do a problem where we actually use the quadratic formula to solve. So we have solved the quadratic equation 3x squared minus 7x plus 2 equal to 0 using the quadratic formula. Now, we could try to factor, we could try to do completing the square, but let's try and practice quadratic formula. As long as our quadratic equation is written in standard form, which it looks like it is, it's in order all to the same side, let's go ahead and pick out the a, the b, and the c. The coefficients. The coefficients on this one, a would be 3, b would be negative 7, and c would be positive 2, making sure you include their signs. Now, let's plug it in to the formula. We have x equals negative, and then b, so there's a double negative, plus or minus the square root of b, which is negative 7 squared, minus 4 times a, which is 3, times c, which is 2, all over 2 times a, so 2 times 3. So your formula should look like mine. Now we just have to simplify. The two negatives in the front make a positive, so I have a positive 7, plus or minus. Negative 7 squared is 49, and then I have 4 times 3 times 2, which is 24, and then a negative in between. So 49 minus 24, all over 2 times 3, which is 6. You notice that I'm being very careful and very organized to do this step by step so that I don't make any mistakes, making sure that I also follow the order of operations, right? Parentheses, exponents, multiply, divide, and then add and subtract. All right, I'm going to go ahead and continue simplifying inside my radical. I have 49 minus 24, which is 25. Oh, look at that. Isn't 25 an actual even root? And we know that square root of 25 is really just 5, right? So I end up getting this equation that says x equals 7 plus or minus 5 over 6. You notice that there's no more radical. I have nice whole numbers that I should be able to continue working with and simplifying all the way down. So really, I actually have two different answers. One that says 7 plus 5 divided by 6, and 7 minus 5 divided by 6. 7 plus 5 is 12. 12 divided by 6 is 2. So x equals 2. I also have 7 minus 5, which is 2, divided by 6, which is really 1/3. So I end up getting two answers. I get x equals 2 and x equals 1/3. Two answers that work in this quadratic equation. Now you notice again that both of my answers didn't have radicals. Do you remember what that meant that I could have done at the beginning instead of doing all of this work? Yep, you could have factored. Try it. You could have bottoms up, you could have factored, and you would end up getting those same two solutions. You could have also divided everything by 3 and done completing the square. Now you're going to have to work with a bunch of fractions, so I don't know if you want to do that. But no matter what method you chose, factoring, completing the square, or quadratic formula, we should always get the same answers. We get these two answers, x equals 2 and x equals 1/3.